Okay, so I can see topics that we need to look at. I have made a video of these first three, so you can look in Canvas to find those. I'm going to go over this one, this distinguishing solid, liquid, and gas. So we'll go over this one together. Okay, so it says we have three sketches and we have different temperatures of HCl, and then we have the melting point and the boiling point. So this is a topic that feels like it should be straightforward, but sometimes it can trick us. So I like to write down the melting point and the boiling point so that I can see what's going on. So melting point is negative 114.8 degrees Celsius. And this is a little bit confusing, so I like to write it like this. So our melting point goes from, I guess, a solid to a liquid. I put my liquid first. Solid to a liquid, or a liquid to a solid for freezing. So this is the temperature that happens. And then we have another point, and I like to put the boiling point above that because that makes more sense to me. So at the boiling point of HCl is negative 85.1 degrees Celsius. So if we have a number line, we have something like 0 up here, positive numbers, let's put 0 here, 0 is here, and then positive numbers are up there. Then we have our other numbers. Okay, if we're going from liquid to gas or gas to liquid, that's our boiling point. So we just have to figure out where these temperatures fit. And if they're negatives, sometimes that's a little bit confusing at what's going on. So I guess we can also draw like a box. So in this box, we would be a solid. In this box, between the melting and the boiling point, it would be a liquid. And above the boiling point, the substance is going to be a gas. So we just have to bin these correctly. So the first temperature is negative 133. And that's below 114, and they're all in degrees Celsius, so we're comparing the same thing. So that's going to be a solid. And then the next one is negative 23, so that's way above negative 85. I guess not way above, that's up here. So that's going to be a gas. And then the last one is negative 102. That's between these two, negative 102. That's going to be a liquid. Okay, so now we know what they are. Now we just have to identify them correctly. So HCl, we have a hydrogen and a chlorine atom. They're bonded together. So we need to look for, at each temperature, we need a model to represent what these are. So the first one is a solid. We need a solid HCl. So remember, solids are going to be very ordered. We have to look for hydrochloric acid. So this one's they're touching, but this one would be a liquid, so not number one. That looks like a gas. There's lots of space between those. And notice we have hydrogen and chlorine, so that's good. That's a good model. Okay, this one's very ordered. This would be the solid version of HCl. This is a different molecule. We have hydrogen gas and we have chlorine gas, or not molecule, excuse me. Hydrogen molecule and chlorine molecules. This is not HCl, so that doesn't work. And then this is not a compound. We have hydrogen atoms and chlorine atoms. That doesn't work either, so let's go back here. So we know this is below the melting point, so it's going to be a solid, and this is very ordered and close together. Okay, the next one we decided, negative 23 is above the boiling point, so that's going to be a gas. So we're looking for lots of space between the HCl molecules. We're looking for HCl. So if we look through, okay, that one, there's lots of space. We have hydrogen and chlorine, HCl atoms bonded together. Let's keep going through and check. This is not HCl, so we can skip that one. This one is a liquid. They're touching. This one is not HCl. It's the atoms that are separated from each other. And this one is also not HCl. This is chlorine bonded to itself and hydrogen bonded to itself. So the best option here was this one. This is a gas because negative 23 is above the boiling point. Okay, and then the last one, we're looking for a liquid. This looks like a liquid because we have hydrogen and chlorine molecules close together. They're kind of sliding past each other. It's not very ordered, but they're close together. This is not HCl. This is HCl as a solid. This is HCl as a gas. There's lots of space in there. And then this, let's see, this is not HCl. So this one is a liquid. Okay, let's check. Okay, let's look at another one. Oh, we just did this one. Let's try a different one. Okay, here's one. So water. So again, we're looking at our melting, boiling, and then where these temperatures fall. And then we have to just come up with the correct model. And if this is something that would be helpful for you to have on a note card, you could put one of these examples on your note card. So again, I like to put the melting point below the boiling point. That just makes more sense to me. So on my number line, we have our boiling point, which is 100. And our melting point is 0. So in between the melting and the boiling point will be a liquid. Below the melting point is going to be a solid. Above the boiling point is going to be a gas. So we just have to figure out, so negative 20 looks like it fits here. That's going to be a solid. The first one's going to be solid. 242 is really high. That's going to be a gas. So 242 degrees Celsius. And then 40 fits between these. So again, we have one of each. I don't know if it's always going to be like that. And then we have to think about, okay, water. Water looks like we're going to have 2 hydrogens on an oxygen. So something like that. Okay. And then for a solid, we're going to have something that's ordered. So very ordered, close together. Liquid, they're going to be close and not ordered. And they can slide past each other. And then gas will have molecules that are far apart. Okay, so let's go through. So this first one was, we need this one to be a solid. So we're looking for water. This is not water. These are not bonded together. So not water, not a good model. This one is a liquid. The water molecules are sliding past each other. This one is a gas because the molecules of water are far apart from each other. This one is not water. We have here on number 4, we have hydrogen and oxygen. That's not water. This is a representation of what water does in a solid. See, it's very ordered. They're close together, mostly. So this one would be solid water. Okay, next one, we're looking for water molecules that are far apart because it's a gas. Oh, I wrote down the wrong number. 249. That doesn't change our answer, but we better write down the right number. Okay, so this one is, there's like sliding past each other. I would say this one looks like a liquid to me. This one is not water, so we can skip that. This one, though, they're super far apart. That looks like a gas. Let's check the other ones just to be sure. This is not water. This is not water. So let's go back to this one. Water, molecules that are far apart. Okay, last one, we're looking for a liquid. So we are looking for water molecules that are sliding past each other. This one, they're pretty far. I would say that's a gas. This one we talked about, this is a solid. They're very ordered. They're close together. This one is not water. We're looking for water molecules. This is not water. They're quite close together compared to this one. This one, they're pretty close together. There's some gaps, but it looks like they're mostly touching. They're sliding past each other. This one is water as a liquid. So let's check that. Okay,